I'll be building the Cygnus keyboard this video, a beautiful board designed by Juha Kaupinen, here in a really clean SLS print provided by PCBWay. The Cygnus is made up of several curvatures, giving it an elegant shape, and the case's two halves are split along its outer edge, which fit together nicely in the 3D print. The SLS print process leaves a textured matte surface, which I like for desk use since it prevents any fingerprints from being left on the keyboard. Inside the bottom case, we have standoffs for screwing the two halves together, as well as bits to hold a controller, reset button, and since I'm building the Bluetooth version of the Cygnus, the power switch. These angular cutouts are to provide space for the PCBs, which will go in here at some extreme angles to allow for the ergonomic shape of the keys, while keeping the case as low profile as possible. The top case holds the switches nice and snugly, and has 4 tiny screw holes per switch to allow for the PCBs to be screwed in place. We'll be using brass-heated inserts inserted into the top case, which will allow us to screw the two halves together. I just used my soldering iron at a high enough temperature to slightly melt the SLS print to press in the brass inserts. I only exert a very slight pressure, letting gravity do most of the work, to allow for the brass to enter the hole cleanly. Getting the insert in flush and level is always a bit of a pain. Here I stopped slightly before it was flush, and used the flat side of a butter knife to push in the remaining bit. The PCBs were also provided by PCBWay, and are single switch PCBs, which will be broken apart for each individual switch. They were originally designed for the SU120 keyboard, and were modified by Kissetfall for use on Dactyl style keyboards like this one. These were really easy to order from PCBWay by simply uploading the Gerber files. The process was just as simple for the keyboard itself, where I uploaded the STL models of the keyboard and selected which material I wanted. The parts were manually reviewed, and I got an email with warnings about potential issues with the model, especially about very thin parts. These didn't need to be addressed since the thin parts aren't under any stress. For the diodes, I'll use surface-mounted ones since these will look cleaner and are more compact than through-hole ones. I like adding a dab of solder onto one of the pads, then lining up the diode in the correct orientation, reflowing the solder until it's aligned, and then soldering on the other side once the diode is held in place by the cooled solder. This PCB uses hot swap sockets, which is really handy for a single board setup like this one, since it means you don't have to redo a bunch of tedious hand wiring if you want to swap the switches. The board also supports KL hot swap sockets, but the Cygnus keyboard itself only supports MX. Breaking apart the PCB into its individual pieces was easy along the breakpoints, but I found that I had to do it in one specific direction to prevent the traces from being ripped out. Before I noticed this, I ripped out some traces, but this didn't cause any functional issues. For our keyboard switches, we'll use the Gatoron Oil Kings, a linear switch with a 55-gram actuation weight, my preferred style of switch, and will visually pair nicely with the white case combined with our black and white SA keycaps from DomiKey. These will all combine to a high contrast black and white look, which will really pop on the desk. I popped the switches in first so that everything would be lined up properly before I add the PCBs and screw them in. This is a really good design decision of the case, as it allows for the switches to be hot swapped without having to open up the case. The tiny screws just go straight into the small holes of the print itself. I just added 2 screws per board, as this was enough to hold it firmly in place and makes it easier to undo if you need to replace one of the boards. To connect all the boards into a matrix, I used some solid copper doorbell wire, where I stripped the plastic coating. It's much more convenient to use solid wire versus stranded wire, as you can nicely bend it into the right shape for each connection, and it is much easier to fit inside the holes. You can also easily adjust the length of the connections by cutting it, since you don't have to keep the coating on. I prepared each connection, some more aesthetically bent than others, which took quite some time, but I got faster at this across both boards. After finishing all of them, I soldered them in place, and desperately wished I had some flux on hand, as the solder sometimes just wouldn't flow. I managed to get through both boards while only melting one spot on the thumb cluster, which was hard to reach. To connect the matrices rows and columns, I threaded some thin, flexible wire beneath the copper connections, which helped keep things organized and compact. I just connected the wires to the KL pads, since this would connect each column together. The controllers are powered by 3.7 volt 24 milliamp batteries, which will provide plenty of battery life while fitting on top of the controllers snugly. I snipped off the connectors to wire in a small switch for physically disconnecting the power, especially useful if I want to use the keyboards wired instead of with Bluetooth. The controllers are the NRF 52840 Super Minis, which are super cheap and will allow for our Bluetooth connection. The batteries get connected to the controllers on one side and then via the switch on the other. Here I forgot to turn the switch off while inserting the second cable, and you can briefly see the controller power on. I soldered the column and row connectors using the diagram provided for the Cygnus, referencing a chart on equivalent connectors. The controller's reset pins are soldered up to these small buttons so that they can easily be put into bootloader mode for flashing firmware. They are placed recessed in the plastic to prevent accidental pushes, but can be reached using a paper clip. Additionally, the Cygnus requires these two small 3D printed parts per half, which holds the controller in place. This accommodates a modular design with different adapters for different microcontrollers. With all that in place, the board is complete, and the two halves can be put together. It's a tight fit, and you need to be careful with the battery placement to prevent it from being punctured, but if everything is aligned right, it fits well and can be screwed together. I'm really happy with the black and white look, which fits perfectly with the Dami Key SA keycaps. The final result is a beautiful blend of organic shapes which complement the ergonomic design of a dactyl-like perfectly. The mix of the smooth curves and the hard edges give it a retrofuturistic flavor, like an alternate timeline where IBM produced ergo keyboards. Thanks to Juha for the design, and thanks to PCBWay for providing the 3D print and PCBs. Here's the obligatory typing test. It has a high-pitched stalky sound profile, primarily due to the SA keycaps. I've contrasted it with a much more dense-sounding copper plate keyboard.